The launch of NASA's Voyager probes was like the start of an amazing trip into outer space. It showed that we can keep an eye on not just Earth, but also everything in our solar system and beyond. Even after 46 years, these awesome spacecraft are still giving scientists new and stunning information about space. Although their memory is 3 million times smaller than that of our smartphones, and they're 38,000 times slower than our fastest 5G internet connection, these incredible probes still lead the way in exploring space. And now, Voyager 1 has just made an impossible discovery in interstellar space, one that challenges everything we thought we knew about the universe. It found something so unusual that scientists are left scratching their heads. But what exactly did it find, and how does it redefine our understanding of the cosmos? Let's find out. Background history. On a special day, September 5, 1977, from a place called Cape Canaveral in Florida, something amazing happened. Voyager 1 began its journey into space, launched by a powerful rocket called Titan IIIE/Centaur. Just 15 days later, on August 20, 1977, Voyager 2 joined in, starting its adventure into the universe. Their main job was to check out the big gas planets in our solar system, like Jupiter and Saturn, and the moons around them. But guess what? These space travelers went above and beyond. They went way out into our cosmic neighborhood, breaking lots of records on their astonishing long trip. They've been going longer than any other spacecraft ever, and they've gone farther from Earth than anything humans have made before. They even went into a place called interstellar space, which is like going into a whole new part of our galaxy that no one explored before. These space pioneers, Voyager 1 and Voyager 2, are more than 12 billion miles away from us now. Still, they continue to surprise scientists with the amazing things they're finding out there. And they've recently found something so unexpected that no one saw it coming. The Voyager twin probes have done some awesome stuff. More than 40 years ago, they looked at the moons of Jupiter and Saturn and totally surprised scientists. People used to think these moons were boring and full of holes like our moon, but nope. They're buzzing with activity. Voyager 2 was the first of the twin to swing by Uranus in 1986, and just 3 years later, it zoomed past Neptune. But here's interesting, it's the only spacecraft that has ever done that. As these spacecraft continue on their amazing journey, NASA is doing some tricks to make sure they keep working. They turned off some things they didn't need, like extra parts and heaters, to save power. That way, these spacecraft can keep going strong until at least 2030. For the scientists and engineers who've been part of this incredible adventure from the start, it's a mix of happy and sad feelings. They worked hard, and now, when they thought the Voyager missions were almost done, a shocking discovery emerged from outer space. Data transmission and Voyager 1's discovery. The information sent back by Voyager 1 and its twin spacecraft have become a treasure trove for scientists. They sparked tons of discoveries and got people excited about space. These are two spacecraft that were built extra carefully, kind of like stable platforms, so they could take clear pictures and gather data while zooming through space. Even before they reached the outer planets, their pictures were already blowing scientists' minds. Voyager 1 started sending pictures of Jupiter even though it was still far away from the planet. People at NASA's Jet Propulsion Laboratory got excited when they saw the first pictures of Jupiter's swirling clouds and the famous Great Red Spot. But the big moment came when the Voyagers found something amazing on Jupiter's moon, Io. This moon, a bit bigger than Earth's moon, turned out to be the most active volcano in our whole solar system. Voyager 1's tools picked up weird signals from Io, and the pictures they took showed huge volcanic eruptions and stuff flying out into space. One of Io's volcanoes, called Pelée, erupted tremendously high, even more than Mount Everest, and covered an area almost as big as France. The Voyagers combined took more than 33,000 pictures of Jupiter and its moons. They showed how stunning Jupiter is and all the different landscapes on its moons. And before this recent and more shocking discovery, these twin spacecraft have been finding awesome things since they started their trip. Another big surprise was finding out Jupiter has rings, although they're not very bright. This discovery made Jupiter even more interesting. Also, Voyager 2 discovered that Europa, one of Jupiter's 53 moons, has a thick icy shell, more than 60 miles thick. These discoveries made scientists rethink what they thought about these faraway things in space and got them curious about whether icy moons like Europa could be places where life could exist. As the Voyagers left Jupiter, they got a boost from the planet's gravity that acted like a powerful kick, sending them towards Saturn. This kick was exceptionally important because it helped them break free from the sun's pull and keep going into space. Voyager 1 and Voyager 2 went their ways after that, heading to new places. Voyager 1 got close to Saturn's moon Titan, which has a kind of orange, hazy air around it. Scientists got curious about Titan's mysteries, so they studied its complicated chemistry. Then, Voyager 1 turned away from the other planets and started going beyond our solar system. On the other hand, Voyager 2 had some amazing adventures too. In 1986, it flew by Uranus and found 10 new moons, adding to the total count. 3 years later, it reached Neptune, showing us the amazing things about this faraway ice giant. Voyager 2 even measured winds on Neptune going as fast as 1,000 miles per hour, the fastest ever on a planet in our solar system. When the spacecraft got close to Neptune, just 2,980 miles away, it gave us new and incredible details about this distant world. Neptune's biggest moon, Triton, turned out to be one of the coldest spots in our solar system, with temperatures dropping to a freezing -391 degrees Fahrenheit. Triton also had these cool ice volcanoes that shot out nitrogen gas and icy stuff into its thin air. All these discoveries made us realize how different and interesting the planets and moons in our solar system can be, even the farthest ones. Imagine a space adventure story, and one person who made a big difference in keeping it going was the famous stargazer, Carl Sagan. He was part of the team that took pictures for the Voyager mission, and he wanted to snap one last set of pictures before turning off the cameras. These pictures would be like a special gift for everyone on Earth, a final look at our home from way out in space. Sagan didn't give up, and it paid off. On Valentine's Day in 1990, Voyager 1 turned its camera back towards the inner solar system and took 60 pictures. The most famous one is called the pale blue dot. It was taken from 3.8 billion miles away, making it the farthest picture ever taken of our planet. In the photo, Earth looks tiny, like a pale blue dot, in the huge space around it. Even after 40 years, these spacecraft are still out there, sending us important information from the farthest parts of space. Now, let's talk about something a bit old school. The Voyager probes use an ancient 8-track tape system. Yes, you heard it right. 8-track tapes were a big deal in the 70s, and these probes are still rocking them. It just shows how smart the people who planned this mission were, making sure these old tapes could still do the job. But why 8-track tapes, you might be wondering? Well, that's a story worth hearing. You see, in the early days of exploring space, the kind of digital storage we use today was just starting out. So, they needed something tough and reliable to store important data, and those 8-track tapes turned out to be the perfect choice. What's even more interesting is that the info on these tapes isn't just regular music, it's valuable science data about planets, moons, and space between the stars. Yes, these tapes hold the answers to some of the biggest mysteries in the universe. Now, think about this. The Voyager spacecraft faces crazy things like astonishing hot and cold temperatures, space radiation, and the emptiness of space. But unsurprisingly, these old explorers keep going strong. It's like sending your grandparents on an adventure in Antarctica, and not only do they survive, but they thrive. Why the Voyager missions worked so well? The Voyager missions had this awesome move called gravity assist maneuvers. Think of it like this: Voyager 1 and Voyager 2, two bold space explorers, were on a big mission to explore the way out in our solar system. To get to these faraway places and gather important information, they needed a little help, something more than just their engines. Here's where gravity assists come in, and it's kind of like a space dance. Instead of only using their engines, these spacecraft did this cool celestial dance with some of the solar system's big planets. They used the strong pull of these giants to slingshot themselves forward, saving fuel and getting the speed they needed to visit lots of different places. Now, let's go back to the basics. Gravity assist, also known as a gravitational slingshot, is about grabbing some speed from a planet as the spacecraft goes by. Imagine Voyager 1 rolling up to Jupiter, a huge gas giant with a pull to match its size. The smart minds at NASA's Jet Propulsion Laboratory made sure Voyager 1 swirled past Jupiter at just the right angle and speed. Jupiter's gravity pulled at the spacecraft, making it go faster, like a space power-up. But here's the tricky part, there's an art to this move. If Voyager 1 had approached Jupiter the wrong way, it could have been a space disaster, sending the spacecraft way off course. Luckily, the NASA experts aced it, and the cosmic dance with the planets was a big success. The level of accuracy needed is mind-blowing. But guess what? The clever scientists and engineers who planned this cosmic dance didn't just get it right once, but many times. Thanks to these gravity assists, Voyager 1 and Voyager 2 went on this amazing trip through the solar system. Voyager 2, for example, used boosts from Jupiter and Saturn to zoom to Uranus and Neptune. These space dances played a huge role in making the grand tour happen. Without these slingshot moves, the Voyager missions wouldn't have been as awesome as they were. Voyager 1 made it to interstellar space, and Voyager 2 wasn't far behind, thanks to the tremendously precise gravity assists they got. The idea behind gravity assists is simple, but making it happen is complex. Voyager 2's grand tour needed a ton of precision. If they missed any of those boosts, the whole mission could have gone wrong. But the folks running the show were very determined to get all the knowledge they could. Attempts by scientists and astronomers to fully understand the concept of gravity assist led them to uncovering something even more sinister about the dark expanse of outer space, the Deep Space Network. The Deep Space Network, even though the Voyager missions used gravity assist maneuvers to navigate space, there's another important thing that made it all work: the Deep Space Network, DSN. Think of it like a space phone line that kept us talking to our brave Voyager probes as they went into the unknown. Now, what exactly is the Deep Space Network? It's not as flashy as a spaceship, but it's extremely important. The DSN is like a big network of radio antennas in different parts of the world, like California, Spain, and Australia. These giant dishes, some as huge as 70 meters across, act like space megaphones, helping us talk to spacecraft that are way out there. Let's get into its role in the Voyager missions. The Voyager probes, with all their cameras and sensors, were our eyes and ears in space. To understand the data they sent back and tell them what to do, we needed a strong communication system, and that's where the DSN came in. Imagine this: Voyager 1, heading to the outer parts of our solar system, sends a message back to Earth. It's a faint signal, moving incredibly fast through space. By the time it reaches Earth, it's really weak. But the DSN's big antennas are ready to catch that weak signal. They lock onto Voyager's whisper and make it into data that scientists can use. The DSN doesn't just catch signals, it also sends commands. You see, missions like Voyager are always changing. Scientists and engineers need to adjust their plans or tell the spacecraft what to do. They send these commands through the DSN, shooting them into space to reach Voyager. It's like a two-way chat between Earth and the farthest human-made things in space. One awesome thing about the DSN is that it works all the time, 24/7, always listening for those far-off signals. The Deep Space Network is like our space connection, not just a bunch of antennas. It's what keeps the tails of the Voyager missions going, even as the spacecraft goes way beyond our solar system, exploring the unknown lands of interstellar space. The Oort cloud, heliosphere, and heliopause interstellar space is a bit easier to reach than the far end of our solar system. Imagine the solar system as a balloon, with a cloud of comet-like things far away, held together by the sun's gravity. This Oort cloud might stretch halfway to the closest star, and it will take the Voyager probes about 300 more years to get near its edge. Now, when we talk about interstellar space, it begins where the solar wind, a stream of charged particles and magnetic fields from the sun, ends. The solar wind acts like an inflating balloon, forming something called the heliosphere. This is like a protective bubble around the solar system, carried by the solar wind. Eventually, this bubble gets stopped by pressure from interstellar matter, forming a boundary called the termination shock. The border between our solar system and interstellar space is known as the heliopause, estimated to be quite a distance away. Back in the day, some guesses put it as close as Jupiter, but more accurate calculations in 1993 said it's around 25 times the distance from Earth to the Sun. $1. Voyager 1 reached this boundary about 20 years after these calculations, detecting a rise in plasma density. Now, Voyager 2 reached the interstellar seashore in 2018, but it didn't notice any changes in the magnetic field. This was surprising, as theories expected fluctuations tied to the Sun's 11-year cycle. The solar wind was strongest when Voyager 2 arrived, challenging these predictions. As the Voyagers provide real data, scientists are refining their models of how the heliosphere interacts with interstellar space. In simple terms, our Sun left a hot, ionized zone and entered a partially ionized section of the galaxy. The hot zone likely formed when nearby ancient stars exploded in a supernova, heating the space and messing with nearby atoms. Picture it like the seaside, with waves and water swirling. It's a bit tumultuous. Magnetic fields twist and turn in this lively area, not the smooth ones theorists usually draw. Because of the heliosphere's impact on the space between stars, the Voyagers found lots of small changes near the heliopause, but not much difference in magnetic fields at bigger scales. Eventually, the spacecraft will leave this turbulent region and hit the pure interstellar magnetic field. Saying goodbye to these cool spacecraft won't be easy. Both Voyager probes still have operational instruments, driven by a system that turns heat from plutonium's decay into electricity. But the power output is dropping by about 4 watts each year, putting the team in triage mode. It's fascinating to watch the Voyagers explore space, but as they move on, we're getting ready to say farewell. The Voyager probes will keep on exploring, even if they can't talk to us anymore. Voyager 1 is going to swing by Proxima Centauri, our nearby star buddy, in a whopping 16,700 years. Voyager 2 will catch up a bit later, in 3,600 years. After that, they'll be circling the galaxy for millions of years, way after our Sun is gone and the heliosphere has disappeared. All of this, just for that one little pale blue dot we call home. It's like their cosmic adventure never really ends. The Voyager probes might still be out there, not too beaten up. They could maybe send a last message during their trip, but not on the radio, and not by us humans. They have 2 recordings, kind of like old-school tech but cooler. These records are made of copper, have a shiny gold cover, and are wrapped up in aluminum. Now, these records, nicknamed the Golden Records, have cool stuff encoded in their grooves. There's about 90 minutes of music, like Bach's Brandenburg Concerto No. 2 and Chuck Berry's Johnny B. Good. Plus, there are pictures of kids, dolphins, dancers, sunsets, and sounds of crickets, rain, and a mom giving her kid a smooch. Even Jimmy Carter, the president when the Voyagers launched, left a message. It says, "We cast this message into the cosmos." It's a note saying, hey, we hope that someday, after we solve our problems, we can join a group of civilizations out there. This record is like a hope and goodwill message from Earth to the huge and awesome universe. Do you think these probes are still the best in the outer space? Let us know in the comments below.